Hello everyone, my name is Andrea Cornaglia, and today I'm going to give you an introduction on Three.js, or rendering 3D on the web. What is Three.js? As you may have guessed from the previous slide, it's a JavaScript library that renders high-performance 3D objects on the web. And it's built on top of WebGL. So for example, when you write your JavaScript code using Three.js functions and methods, that gets converted into WebGL, which your browser, for example Chrome, can read and transform into OpenGL. We can talk directly with your display driver. And this will allow your hardware to render your 3D scene on your screen. So why do we want to use Three.js? As I mentioned, Three.js is built on top of WebGL. And one of the advantages of Three.js, as opposed to WebGL, is that it's a high-level code, so it provides us with a lot of high-level abstractions. So for example, if you want like a scene or cameras or lights, that's being provided for you. So you just need to put it on your code, and that's it. So what will take you, for example, if you want to render a spinning cube, on Three.js, it will take you like around 20 lines of code, and WebGL will be 200. So you can see how you write less code, and sometimes it could be even more higher performance. Also, another advantage of Three.js is once your code is already running, your application, it's very easy to make it VR compatible using like VR headset. So that is pretty cool because VR is very popular now, and you don't really need to use other external applications or libraries. You just use Three.js. And finally, in general, having 3D graphics on your website can make it into a more immersive and interactive experience. So it can really give more user engagement to your website. So I wanted to show you some examples of how developers are actually implementing Three.js on their websites. So you can see how you can use it to browse a product and see, for example, different colors and angles, data visualizations, for example, music, or Twitter.js data, and some interactive experiences like Harry Potter, and 3D games, and even VR immersive experiences. So before we dive into the code, I wanted to explain a little bit of how we actually transform a 3D scene, how we render a 3D scene into a flat screen, like your monitor. So we need different elements. First, we need a scene, and that is like a stage. That's where all your elements are going to be placed. And then we need a camera, and the camera will look into some part of some angle of your scene, so it will be like your eye. And we need a light, and the light allows us to see the objects because of the light that is reflected on them. And finally, we need an object, or several. And in Three.js, the way we make the objects is we need two parts. We need a geometry, and we need a material. And a geometry is like our skeleton, and it will tell us what shape our object is. So it could be a cube, it could be a cylinder, it could be a custom object. And it's interesting to note that all objects are made out of triangles. And also we need a material. And a material can be either a texture, for example, wood or metal, or it could be just a plain color. So when you put them together, you have a mesh, and the mesh is going to go to your scene. So now let's look at some code. First of all, we need to import Three.js library. So very straightforward. And now we can already start coding with JavaScript. So as I mentioned, as I showed before, we need to create our scene. So we use the Three.js constructor functions. So we have a scene, and we have our camera, and we have a renderer. And we want to attach the renderer to the DOM, so we can actually see our scene into our website. Now we can add our element. In this case, we're going to add a simple cube. So we use Three.js box geometry, and we give them the X, Y, and Z coordinates. And we add the material, and we put them together in the mesh and add it to the scene. And an interesting thing to notice here is because I didn't define any position to the object, so by default, Three.js is going to put it at the center of our scene. So we need to move the camera forward so we can actually see our object. So that's why on the last line, we're changing the camera position. Finally, in order to make it happen and to be able to see our scene, we need to call render function. And this render function is going to be called 60 times per second. And that'll give a more natural feel to our scene and a more interactive feel. And we want, in this case, we want to make the cube animate. So we're going to call request animation frame. And as you see here, we're going to make the cube rotate. And we call render.render. So this is our cube. As you can see, it's very simple, but we can already see some of the 3D concepts. Now, how can we make it a little bit more interactive? An easy way of doing this is adding user controls. The most common user controls are called orbit controls, and this is a library that you can import, a Three.js library you can import. And what this allows is the user to use the mouse or the keyboard controls to go around the scene and zoom in and zoom out. So once we create the controls and attach an event listener, so now, for example, I can look at the cube and I can zoom in and zoom out. And finally, I talk about VR. And I wanted to show you how simple it is to add VR functionality. For this, we are going to use the stereo effect library. And this will allow our screen to divide into two parts. And that generates the effect of VR when you have a headset, for example, Google Cardboard. So we create the effect, we add the size, and we render it. And now we're going to be able to see our cube in 3D. So if you put it actually in your phone and in the cardboard or something, you'll be able to see the cube in 3D. And finally, we talk a lot about cubes. So I wanted to show you how you can do something more interesting. A good thing about Three.js is that you can import custom objects. For example, you can create them yourself. You can use Blender or other 3D libraries, or you can find them on the web. There are a lot of free resources that you can use. And you just need to make sure that you have two files. You need an OBJ file and an MTL file. The OBJ file will be more like we mentioned, like geometry, the shape, and the materials. MTL will have all the materials. So we use these two loaders, the MTL loader and OBJ loader provided by Three.js. And in this case, I'm altering a little bit the position of the object because depending on how the model was constructed, you have to kind of reset, so making sure it's in the origin. And now we can see our object. And we can also zoom in and look at it, and you can see how you can little by little start making your application more robust and interesting. So I hope after this presentation you have a better understanding of Three.js and you're inspired into adding more 3D in your projects. Thank you.